Now let's take a look at the Dense Pack insulation tool. This solves for both installed density and bag count. Bag count is now selected for the result, and we can also solve for insulation density. I'm going to go back to bag count. We're going to do an example for Dense Pack cellulose insulation in a wall cavity. Let's now look at the inputs. For the inputs, we have the insulation bag weight. For cellulose, this is generally between 25 and 32 pounds per bag. I've entered 30 here. For framing, we have either hidden framing or exposed framing. My example will be for hidden, but if I did it for exposed, we would be able to see the framing. We could measure it and include it in our measurements. Because we're doing a hidden one, we don't know that, we can't see it, so the tool makes certain assumptions, and I'll show you what those are. We've got gross area. This is the area of the wall that we are dense packing. Notice that I've entered math on the fly here, so when I click outside the box, I get my result. The fenestration penetrations area, this is windows and doors and other things that are poking through the wall that impact the square footage. I've entered 280 square feet. Here for the 1816, the 280 square feet is subtracted from the gross area that I entered. Now we're on assembly type. This is for the hidden. We have wall, ceiling, and floor. Notice if I click on the assembly type for the pop-up help, you can see for the ceiling, the framing, which is hidden, is 6.9%. For the wall, it's 25.4%. A significant amount of the wall is framing. So wherever there's framing, of course, we cannot put in dense pack insulation. And for the floor, we have 12%. So those are included as part of the inputs that are under the hood for the tool. So the cavity area, what we have here is the gross area here. Subtracted from that is the fenestration penetration area, and then we have the over 25% of the framing area subtracted also here. So the cavity area, notice that's in square feet, for 1,350 square feet. The cavity depth, I've stated that's 3.5 inches deep for modern 2x4s, and the cavity volume therefore is 395 cubic feet, which must be filled with cellulose. Now down to our results. We are solving for bag count. We want an installed density of 3.5 pounds per cubic foot, which is appropriate for cellulose. It would be 3.5 pounds per cubic foot up to 4.5 pounds per cubic foot. The bag count would have to be 46. Now, if you're a contractor, you're going to a job, you're wondering how much cellulose to take. 46 is a good amount. But if we go to the high range for cellulose of 4.5 pounds per cubic foot, we click outside of the box, we see that we have 59. So we could take between 46 and 59 bags with us to this particular job. I'll go back to 3.5 for this, click outside of the box. Well, you might be asking, why would I want to solve for the installed density? What if for the same house a contractor says, or say a subcontractor that you've hired to do this house says, Well, yeah, I did that just fine. I've got proper density. In these walls, I put in 40 bags of cellulose. You put 40 here. It's solving for installed density. You see that you get just over 3 pounds per cubic foot, which is an inadequate dense pack. We need at least 3.5 pounds per cubic foot for it to be dense packed cellulose.